Hello, it's me, and we're going to start a little tutorial series slash couple of demonstrations on this thing called a bandaged cube. Now, there's different ways of bandaging this. Now, this is a little bit of a stray in what we've been doing previously, the modifications where you take a familiar shape and turn it into something else, basically rendering it into a shape-shifting supercube. We've seen the different types of shapes that you can get there from octahedrons and whatnot, or dodecahedrons. We've seen jumblers, we've seen edge turners, face turners. Well, we had one example, actually a couple of examples of going back to the 3x3 concept and making changes into it where you can't apparently use strategies to solve your standard 3x3. This being, of course, your standard 3x3 over here. So what we're going to look at is a couple of examples of how they will take a 3x3 and change it enough to where you can't apparently use the same type of strategies. Now, there's different ways of bandaging. And we've talked about concepts of shape-shifting and concepts of jumbling. Bandaging is fairly simple. It's basically where you take an internal mechanism of one puzzle and you limit it so that it can't make certain movements that it otherwise would want to make. The first example that we saw of that was, of course, this latch cube. Now, this is a type of internal bandaging where we can see where the bandage is going to happen. We can turn it in one direction, but we can't turn it in another direction. Because it's blocked, that inherently is what bandaging is. Now, the difference between something being bandaged and something being jumbled is when something is jumbled, it's the external structure that prevents a move from being undone. And you actually don't have any way of getting it out of it. It's actually the external and the internal structure. You can try to cut it so that you can remove the jumbling effect, but you're going to jumble it somewhere else, basically. I don't want to get too much into detail with this, but that's how you can kind of tell the difference between those. In the case of these bandage type puzzles, the internal structure is the same. These are all basically 3x3s. The main difference is that you have some kind of a mechanism that's been added to it, either an internal bandaging process that happens on the inside that you can only see based on these arrows, or an external bandage where you've literally glued segments together, but otherwise it's a perfectly fine functioning 3x3 internally. Another example of a bandage would be this. This is the White Eden circle 3x3 with two circles, top and bottom. Both of them turn with the centers being bandaged. In other words, the center doesn't move. And we have to deal with that. But the bandaging goes beyond that, because if I make a turn down here, now this whole side is bandaged. So because of that, these are variations on the 3x3 concept where there's these three different types of bandages where you have internal bandaging that prevents undoing a move that you just made. This is kind of a sort of a cut type bandage where you cut through and seal it all the way down to where you can't make certain moves. And this is purely an external bandage, which is actually fairly simple to put together yourself. This one is put out by Meffords. There's a couple of variations of the 3x3 bandage cube that we're going to go over. We're going to start off with this one, and I have a reason for doing that, which we'll discover. This is what's also referred to as the Bicube, maybe because there's really two areas at any one time that you can turn it in, perhaps. But in any case, there's another 3x3 bandage called the Bandage 3 that we're going to get into next. But we're going to start off. With this. So really, to solve this, we're going to be making use of two algorithms, just two algorithms. Well, looking at this, you can see that based on the structure of this, there's one piece here, which is this piece that I have in the upper right corner, looks like the standard 3x3 piece. It's not bandaged at all. And then there's three other types of bandages that you're going to see here. There's one where you have the center and an edge that's bandaged together. That's this one, and this one. Then you're going to have a bandaging of edge and a corner, which is this one, and this one. And then you're going to have one big old bandage where you have a center, an edge, and another center. So this big uber bandage over here. Now, for purposes of demonstration and of future puzzles, I want you to look at the organization of this cube. In order to solve this, you generally are the only way to get the motions and the movements freely with this is to let this part here kind of be your guide. So wherever this goes, that's where you're going to be able to maximize your motion and to have either 2 moves or 1 move. So I can move it here, and as long as I'm leading with this, I'm able to move this puzzle around. But obviously, I can't move it consistently independent of that. So if I wanted to design algorithms that were similar to what I've been using, I have to somehow lead with this guy in order to do it. And you know, I'm able to do R moves and U moves, or perhaps L moves and U moves as well. The way that we're going to have our sort of baseline organization is looking like this, where you have all of these here in an upright position, everything in the front, everything to the left, and to the side you're going to have these 2 laying on its side basically, and in the back here these are going to be up front. So really it's just these 2 that are going to be laying on its side. Up here it's going to be oriented like this, so you're basically going to have this kind of surrounded by banded sides like this, and the bottom part is going to follow suit. That organization is going to be important for future bandage solves as well. Just to kind of review the algorithms of what we're going to be dealing with, there's going to be 2 algorithms that we're going to have, one of which is going to spin these top layers around. It's just going to cycle these 3 around, and another one is going to take these edges and move them around as well. Now the problem with that is it's a 5 cycle algorithm. So you're going to cycle 5 things around, which means we may have to do some fancy footwork. It's easy to cycle 3 things around and come about some known endpoint, but 5 things, that's a little bit top heavy. So if I wanted to move edges around, if you recall, there was a edge turning algorithm that caused your edges, at least on the top layer, to do some flipping. So we'll recall the algorithm on a 3x3 that basically wanted to flip these around, and that was going to be the F, R, U, R, I, U, I, F, I. And what that did is that flipped some of these guys around, and as you recall, we looked for the L formation. Now, if I were to apply an algorithm something like that, it's going to do something similar. It's going to cause a flipping effect with this. But because I'm going to have some edges that are bandaged to corners, I'm not just going to flip these. I'm actually going to take them off of their respective side and cause something of a rotation and a permutation of all of them. So let me show you what I mean. The algorithm is going to have the same kind of a form. It's going to start off with F, R, U. But instead of doing R, I, U, I, F, I, I'm not going to be able to do that because I'm going to be blocked. So what's going to happen if I do the same thing but with a slight variation? This is for the purpose of flipping edges, not rotating it, but flipping edges. But this variation, in order to stay within the confines of what I am able to not move, is going to be F, R, U. But instead of doing an RI, we're going to do a F, then a RI. So now we have our RI. But then we go 2F, and then UI. So let's take a look at exactly what that algorithm did. It took this one, this red and blue, and put it over here. So, well, actually, it put it over here. So this went to here. This, which was the red and orange, went down here. The orange and green went up here. The green and yellow went over here. And the yellow and white went down here. Now that's a mouthful to remember. How could I possibly use that for the purposes of solving? But it's not so much what it did move around that's going to be important. It's what it didn't move around. It didn't touch any of these edges over here. So it was isolated to the edge corner matchups. So none of the center, none of the middle and edge matchups, bandages were affected. It was all corner edge matchups. So this moved here, this moved here, this moved here, this moved here, this moved here. But this didn't move, and this didn't move. So that's going to be important, and that's going to be the more important thing to bear in mind as to what's going to happen with that specific algorithm. So if I do it again, F, R, U, F, R, I, to F, U, I, same thing, not touched, but everything else moved around. Now because this is a 5 cycle, I got to do that 5 times to get it back. So that's what I'm going to do. Okay, so that brings it back. So that's algorithm number 1. Algorithm number 2 is going to be something that's going to only be working on this one layer. Now you recall that one when I wanted to rotate these around, but I did not want them to flip. just rotate but not flip, that was going to be the R, U, R, I, U, R, 2U, R, I. Now what that did is that basically kept this one constant and flipped these around. So I'm going to pattern that same algorithm, and this is how I remember it best, is I want these to rotate around as well. And it's going to have the same form, which is going to be the R, U, R, I. But I can't do it exactly the same because I'm going to get blocked. So in this case, it's going to be R, U, R, I. I can't do another U. So in this case, I'm going to do a 2F, and then a L, then an F, then a LI, UI, F. So the end result of that is this layer wasn't changed at all, but this red and yellow went to here, this green and yellow went to here, and this white and yellow went to here. Something really to notice, if you wanted to dissect this, this is a 3-cycle move, so 3 times we'll bring it back. But the whole purpose of this, much like we did with here, is we rotate this around and we want to reconstitute this side here. So basically, if you pay attention to what's happening, R, U, R, I. Now I want to get this back in conjunction with this one over here. So hence we do our 2F, bring this back down here, which now puts this back in line. Now I got to move it back up to here. So I move it up here, turn it up in here, and then bring it back over here. That's well, bring it back here and then move it back down. So that's kind of how to visualize exactly what's going on. And then that brings it back. So here's another aspect to understand. With this puzzle, actually scrambling it is almost as difficult as solving it, because I actually have to use algorithms in order to scramble it. Otherwise, you're going to see pieces just stuck together. Yeah, I could have some limited scrambling with this, but unfortunately, these and these will almost never leave. So to do that, I'm actually going to demonstrate how to maybe pull this out and also pull that back in. Notice if I wanted to do that, what I could do is I can move this up here, and that makes all of this entire layer, look exactly like each other, which means I can move this in and move this down. And what I did is I pulled this out and I didn't change the Bicube structure to do all the algorithms that I wanted to do. So now what I could do is I could do an algorithm, the same algorithm, which will take this, pull it out, and put something else in here so that when I move it back, this is now out. So I'll just do the FRU, FRI to UI, and basically that's been taken out. That predictably went up over here. Now I have to be careful once I do that. The form won't be exactly the same. I actually have to lift this up, come back here, and move it back down. That'll make me able to really launch this around. So let's say I do the RURI here, that same algorithm, and bring that down. So that's how I get that out of here. How about getting this out? Well, it's important to talk at this point about the equivalency of positioning with this. So as long as this is to the right, then I'm doing okay. So I can rotate the whole puzzle counterclockwise, and this is still to the right, so I still have some limited abilities to do some of the algorithms. Granted, my big bandage side is now on the side here, but I can still do much of the other algorithms that I had, which means this one, which was locked into position, now when I hold it here, this is no longer locked. This is, and this can come up over here. So FRU, then do my FRI to F here, and now this is gone. So I can move this back, and you can see that now this is gone. So this is out, and this is out. That's going to be important for moving it in. I also want to point out that not only can I rotate it once counterclockwise rather, I can do it twice and still get the same effect. Still be able to move it around, so I can kind of variate my motions a little bit here, but do the same movements. When I'm scrambling this, the first thing that I'm doing is I'm trying to get all of my corners out. So that's what I'm going to do first. I took these corners out, and now I'm going to use the same algorithm to just kind of rotate things around here. FRU. This got in, so FRU. And I'm just going to do this until I see that no corners are really where they want to be. Now, it's just for the sake of doing RURI to F, L, and here. So that's doing pretty well. So once I've done that, now I'm going to want to mix up the centers, because no matter what I did, no matter how much wrangling I did, my centers never changed. So to move the centers around, I'm just going to do a random scramble at this point by moving this guy around. And as long as I'm leading with a bandage side that's running along with this, not against this, along the same plane, I have pretty much freedom to move it anywhere. So what do you think? Pretty well scrambled? Okay, so I'm just going to kind of reverse the steps that I did. Obviously, we're not in any of the structure that we want. So we're going to use those two algorithms to guide our way through. The first step is we're going to take our our non-bandaged corner here and find the most bandaged area and move them directly opposite. So what I actually want is I want this, say over here, with this one directly behind. Now the question is it like this with a white one on the bottom? Or do we put the orange one on the bottom and have it, like this? Well, it's actually the orange one that's on the bottom. And the reason why is because notice I was able to pretty intuitively put the yellow to yellow, green to green, and red to red. If I tried it like this, it wouldn't work. I'd have the red here, but you can see that there's no way to get the orange and green at the same, at the right place and have this up and to the right. So that's how it's going to be, and that's just something that you discover over time. Okay, so the next part is I want to get the cross. Okay, so the first part is we want to get our cross in. Now I'm going to define the cross that I want to put in as a combination of a bandage center with an edge. I'm going to ignore the edge and corner bandages. I'm just going to do it based on all the edges that have a bandage with a center, and that's where I'm going to. That's what's going to be held into place when I do all of my 3 cycles. So this obviously belongs down over here. Here's our corner. Here's our corner piece over here. Well, and then here. Now this has to move down, so I'll move it again, and bang, that's down over here. Now I need to move this white with this white over here. So I can actually move it down like that. So that's in. And now last but not least, I need to move, this is already in. Okay, so basically this represents my cross. The only problem is that this is not lined up quite right. So I've got to move this around until, there we go. Okay, so this is good, this is good, this is good. Did I blast anything out? And yeah, so this has to make its way down despite the fact that these guys are in. To see if maybe I can get this in. This is where it needs to be, but I can't seem to get this back in here. So I'll turn this like so, and then move this over here, move this back up over here. So no doubt about it, this has to come down here. And now this has to come down over here, and then this comes over here. So, okay. So we did it. This is good, and this is good, and we have our cross. Now, again, I didn't really have much of a strategy with that. I just had to kind of slowly put it in. So step by step, what I'm going to do first is there's an order to things. The first thing I want to do is let's put in the corner slash edge bandages that are locked into position. So that's going to be here first. So we're going to first start off with a corner that's back and to the left. And that's going to be the blue and white one. So we find it, blue and white is over here. So what I'm going to ultimately want to do is I'm going to want to put this into this position here. I'm going to use that trick that we talked about. I got to move this to here. So I'm going to move this up so that everything here is standing to attention. Move this across and then move it down. So now with that algorithm, this is in line for this to come down here. So we're going to do our F, R, U, F, R, I, to F, U, I. So now that's down here. We have to be very careful to move it back because this is not in the structure that we're going to be able to use to solve. So move it back up with an R, and then we'll do a D, I guess, and then move it back down again. So now this is in place. Step 2, put the other one in place. We need to put in the red and the green. So how are we going to finagle one into here? Well, let's find the red and green first, which is right over here. What we're going to want to do is this is locked into position, but remember, if I turn this counterclockwise, this will no longer be locked in position. What I just did, the one that I put in here, isn't going to be affected because it's still back into the to the left. But this can be accessed that way. And the way that that algorithm is going to work is it's going to move this one into here, which means I need to move the one that has to go here first. So I'm going to do the algorithm until this guy slides into here, which will be 1, 2. FRU. Okay, and do it once more. FRU. Bang, zoom, pow, splat. Okay, so it's over here. Now this is going to come over to here. So let's go ahead and do our rotation and do the same thing, which will turn this over here. FRU, FRI to FUI. And there we have it. So this is in and this is in. So now we've got these locked into place. So how are we going to coordinate a 5-cycle algorithm to cycle in these things in the remaining corners/centers in the proper configuration? Well, the next one that we're going to do, because it's easy, is we're going to do this one. Because recall, at the top, I had a way of isolating the top. So we just need to put these two in place. And we're going to do this one over here. So I'm looking for the green and orange, which is right over here. So just keep doing the algorithm until this goes into here. So just one more should do it. FRU. And as promised, there it is. Okay, what about this guy? Now, how are we going to get this in without destroying everything else? Well, we're going to have to do a little bit of fancy footwork. And if you can get this little nuance, then the puzzle is going to be really easy for you to solve. We're going to make use of the fact that as we turn these in a counterclockwise position and back again, we're going to be able to variably affect these, putting some in and putting some out. And we are going to have to do the opposite of one of the algorithms. So let's consider what's going to happen. Ultimately, I guess what I want to do is I want to take the red and blue one, which happens to be over here, and this is where we want it, because this is how it was calculated to be. If this were anywhere else, we'd have to do the RU-RI algorithm in order to rotate it over to here. Because consider this. Let's track this piece and see what's going to happen. If I turn it over here and do the algorithm, this is going to end up over here. If I turn it again and do the algorithm, this ain't going to change. Actually, I'm not going to do the algorithm, I'm going to do the opposite. But it doesn't matter whether I do it forwards or backwards, this won't change. Then I'm going to turn it back to here, do the usual algorithm that we talked about, the FRU algorithm. This will then come down to here. Turn it back here, and there it is. So in 3 steps, it'll put this to here. What's going to happen with this one? Well, let's chart it out. If I turn it here, do the FRU algorithm, this will come down to here. Then I'm going to come over here and do the opposite. I'm going to do it backwards. By doing it backwards, this is going to be placed back up over here. Not here, but here. Now I'm going to move it over here, do the forwards algorithm again, which will place this back up, which will place this back up to here. So turn it and it'll be exactly in place. So the end result is this will go back and forth and this will end up here. So let's see how that works. Go over here and do the FRU algorithm in the forward position that we talked about. FRU, bang, zoom, pow. Do another counterclockwise rotation over here. Now we do the opposite because we already charted out what was going to happen. Now the opposite, just think of it, you're saying you are F'd twice, adding a little bit of spice into it. So we'll start off with a U, then do a 2F, then pick it up with an R and an FI, then a UI, RI, FI. So it's not too hard to remember, it's just the opposite of the FRU algorithm. Turn it back here, clockwise, and do the FRU. FRU, bang, zoom, splat, and you got it. So this is in. Now it just happened to work out that way, but in actuality, if this were rotated around, or if these were out, then you do the R, U, RI, then you do your 2F, this one over here, and what that'll do is that'll get this into configuration, and these guys will be rotating around. So this will be the last step. You'll have solved this layer here, and you just do that RURI algorithm. RI. And then do it once more. Oh, don't get confused. RURI. And bang, and there you solved your bicube. So it's a pretty quick strategy when applied, but it's very effective. And this gets us through the first of the 3x3 bandages, which will act as kind of our baseline for the bandages to come. So let's see what's coming next. Thanks for watching.